Good morning. This is the lesson for the notes for pre-cal, Tuesday, January the 16th. Okay, I need you to get your week 3 math workshop out. I gave this to you last Thursday or Friday to go on and put in your notebook. If you were not here either of those days and do not find this in your notebook, please get out a sheet of paper and copy the problems down onto it. I would like for you to do 1 through 11 odd right now. Please pause the video and complete 1 through 11 odd, and I will go over this. Alright, number 1, it says evaluate without using a calculator. We have rational exponents. 36 raised to 3 halves. So remember the number in the denominator is the root. Root lives underground. That's how we remember it. Square root of 36. Square root of 36 is 6. 6 cubed is 216. Number 3, 216 raised to 2/3. The cube root of 216 is 6. 6 squared is 36. It says rewrite each expression using an exponent. Okay? We're going to rewrite this. We don't want to find the answer, we just want to rewrite. That's going to be 27 to the 1/3. The cube root, and that's understood 1 power, so 27 to the 1/3. We write this, it will be 16 to the 1/4. The next part says write each expression using a negative exponent. Okay, we're going to work backwards, so that's going to be m raised to the -7th. Because if I had that, that's how I would get rid of the negative exponent. I'm going to write this as 1/2, that's going to be x to the 1/4. Write it as a negative exponent, it's going to be 1 over 2 and x to the negative 1/4. Okay. Remember, when we get back to school, you will have a Trig quiz. Trig quiz number 2 of the 9 weeks. So you can put that away. Now I want you to look at page 19. This was your homework from Friday, 1 through 10. I'm going to work 1 through 10, 1 through 10. It's trig equations. That's going to be continued by learning target days. I can solve trigonometric equations. Same learning target from Friday. Please write that down in your notebook. I can solve trigonometric equations. The learning target days, I can solve trigonometric equations. We're going to look at 1 through 10. Remember, it's very important to read your directions. It says find all solutions on the interval 0 to 2 pi. Remember, 0's got a bracket around it, so 0 could possibly be your answer. 2 pi has a parentheses around it, so 2 pi could not be your answer. But if there was a bracket there, it could have been. Alright, so I'm about to work these problems. I'm working my notebook paper. I just want you to see what page I'm getting this off of, okay? So, like I told you on Friday, when you're doing trig equations, you might want to write some information at the top of your paper so you can see visuals. You know that this is a good visual for some of you. Some of you can do this in your head now, and you don't need to do it anymore. But some of you might still need this visual, okay? And I go over here and find my order pairs. And I'm really concerned about my tangent as well. My tangent of pi over 6. Okay, let's go around here and find it just to make sure you understand y divided by x. I'm going to say y divided by that. So the square root of 3 over 3. Y divided by that would be square root of 3, and this is 1. Okay? Alright, number 1. We have cosine x equals square root of 3 over 2. We have to think what values give me a cosine x equals square root of 3 over 2. Okay, so we're dealing with cosine value is your x value is positive. So we're looking at quadrants 1 and quadrant 4. Which of these have a square root of 3 over 2 is cosine? That's pi over 6. So x equals, we want the pi over 6 family members coming out of quadrant 1 and 4. That's going to be pi over 6 and 11 pi over 6. Number 2, tangent of x equals 1. Tangent of x equals 1. It's a positive one. That means when I divide y divided by x, get a positive. It's going to be quadrants 1 and quadrant 3. That is the pi over 4 family. So x equals pi over 4. That's in quadrant 1. And then 5 pi over 4, which is in quadrant 3. Because you go pi over 4. 2 pi over 4 reduces. 3 pi over 4 is in quadrant 2. 4 pi over 4 reduces to pi. 5 pi over 4 is in quadrant 3. Number 3. cotangent x equals square root of 3 over 3. Well, guys, we don't really work with cotangent a lot. We do sine, cosine, and tangent. So I'm going to rewrite this as tangent x. If I want to do that, I need to flip this because they're reciprocals of each other. So when I flip that, I get a square root in the denominator, a radical in the denominator. So I need to rationalize, and I multiply by square root of 3 over square root of 3, and that gives me square root of 3. 3, because that equals 3, square root of 3 over 3, and those cancel out. So I'm trying to think of what values give me a tangent x of pi over 3. My tangent's positive. You have a positive tangent in quadrants 1 in quadrant 3, because a positive divided by positive and a negative divided by negative. So I'm going to put quadrants 1 and quadrants 3. The tangent, which one gives you a tangent of square root of 3? That's the pi over 3 family. So your x equals pi over 3 comes from quadrant 1, and then 4 pi over 3 comes from quadrant 3. Number 4, sine of x equals 0. This is one of those major points. Which ones give you a sine value 0? That is 0 at 0 degrees, pi, and you will not include 2 pi because in your directions it had a parentheses around it. Alright, number 5. Sine theta equals 1/2. Your sine is your y value. Where is your y value positive? Quadrants 1 and quadrant 2. Which one has 1/2 as sine? Is pi over 6. Okay, so theta equals, what family members of pi over 6 is in quadrant 1 and quadrant 2? Pi over 6 and 5 pi over 6 are your answers. Number 6, tangent of theta equals negative square root of 3 over 3. We think, okay, where would your tangent be negative? Okay, that being quadrant 2 and quadrant 4. Which of the reference angles gives you a tangent value of that? That's pi over 6. So theta equals 5 pi over 6 is in quadrant 2, and then 11 pi over 6 is in quadrant 4. Number 7, cosine of theta equals 0. Cosine of theta equals 0. Where was your x value? 0. Well, pi over 2 and 3 pi over 2. So theta equals 3 pi over 2 and pi over 2. Number 8. 4 cosecant theta plus 6 equals negative 2. Remember, you want your trig function isolated. Like in just all these, your trig function was isolated on the left side. Well, we need to get this isolated. So I'm going to move the 6 over first. 4 cosecant theta equals negative 8. I'm going to divide by 4. Cosecant theta equals negative 2. So I have cosecant theta equals negative 2. Well, I rather work with sine or cosine instead of cosecant or secant. So this is related to sine. So I'm going to write sine, and when I do that, I'm going to flip that because they are reciprocal. Sine. So I'm really looking at sine of negative 1/2. Your sine is your y value. So where's your y value negative? Quadrant 3, and it's quadrant 4. And you're working with the pi over 6 because that's the one that has sine of 1/2. Now, what pi over 6 family members are in quadrant 3 and 4? That is 7 pi over 6 and 11 pi over 6. Alright, let's look at number 9. 2 cosine x plus square root of 3 equals 0. I'm going to isolate my trig function. I'm going to bring this over first. 2 cosine x equals negative square root of 3. Divide by 2. Cosine x equals negative square root of 3 over 2. Okay, so it's a negative cosine. Cosine is negative, so that means it's going to be in quadrants 2 and 3. And it's dealing with pi over 6 family. So which ones are in quadrants 2 and 3? That's 5 pi over 6 and 7 pi over 6. Okay, you can pause the video right now if you need to look at any of those. Got one more for my homework. Alright, let's look at number 10. Four sine theta minus 1 equals 2 sine theta. Now, you want to get your trig function isolated, so you could bring this over here and then take that over here, or you can just bring this over here and get your sines on one side. I'm going to make this minus 5 sine theta minus 4 sine theta. That gives me negative 2 sine theta. Divide both sides by negative 2, and I get 1/2 equals sine theta. So I think, okay, my sine is my y value. Where's my y value positive? Quadrant 1 and quadrant 2. Which one has sine of 1/2? That's pi over 6. Which pi over 6 family members are in quadrant 1 and 2? Pi over 6 and 5 pi over 6 is your answers. Alright. Like I said, our learning target today is I can solve trigonometric equations. I can solve trig. We're still doing the same learning target, but we're just someday going to see more different types, okay? So I need you to turn to page 11 in your notebook. Page 11 in your notebook. And the title of this note taker is solving trig equations by factoring. Yes, sometimes you have to factor trig equations. We didn't get to this in Friday because it builds. Those are the pretty basic ones we did Friday. So let's read our directions. It says find all solutions for each equation on the interval 0 to 2 pi. And notice that both 0 and 2 pi are in brackets. So 2 pi and 0 could possibly be answers. Alright, if you're just looking at this note taker and see the format of them, several of them look like bust them up an easy method because of the way cosine squared, cosine, no cosine, like variable squared, variable, no variable. That's the kind of stuff we're working with today. Like here, they both have a cosine. We could take a cosine out. So sometimes you got to be able to look at it and say, hey, I think I need to factor this one before I solve it. So that is what we're looking at today. I'm going to do these on notebook paper. No, I'm going to do them on here. We're good. All right, so let's look at this first one. Cosine squared minus cosine x equals 0. They both have a cosine in common, so I'm going to take that out. Once you factor that, then you set both of them equal to 0. So cosine x equals 0. Cosine x minus 1 equals 0. I'm going to draw a little picture here just to make sure you see. Now you need to be getting away from this and could do it in your head, okay? But right now, so you can make sure you understand what I'm getting this. So let's know, where does my cosine values equal 0? So x equals pi over 2 and x equals 3 pi over 2. So there's 2 of my answer for that. Now, I'm going to move this one over to isolate the trig function. So cosine x equals 1. Where does my cosine x equals 1? That equals at 0, and because they have a bracket around 2 pi, it could be 2 pi. So that problem there has 4 answers. If you want to box them off, so it'd be easy for me to grade, that would be awesome. Alright, number 2. Your cosine x sine x equals 3 cosine x. You look at it, go, Mr. Escher, I wouldn't know what to do with that. Well, you got to train your mind to think, okay, if they have something common, then you got to factor something out. So if I move this over and get it set equal to 0, they both would have a cosine. So let's do that here. Cosine x sine x minus 3 cosine x equals 0. Now I'm going to take a cosine x out. Set them both equal to 0. Where does cosine equal 0? Pi over 2 and 3 pi over 2. Then I got sine x minus 3 equals 0. Do we have any trig functions? Do we have any values of the unit circle out? What I'm talking about, is there anyone in the unit circle that's going to give me a sine value of 3? No, so you don't have to worry about that. So the only answers you have are these two. You don't have a sine value of 3. Alright, number 3, I see this has cosine this, so I can factor that out and bring this over here. 2 sine x cosine x minus square root of 2 cosine x. I can factor out a cosine x. Now set both of them equal to 0. Where does my cosine get 0? I think I got that memorized now. Pi over 2 and 3 pi over 2. Now set the other one. 2 sine x minus square root of 2 equals 0. I'm letting you get caught up. Alright, now let's look at that and move this over here. 2 sine x equals square root of 2. Divide both sides by 2. Sine x equals square root of 2 over 2. Okay, so sine of x equals square root of 2 over 2. Alright. Your sine is your y value. Where's your y value positive? Quadrants 1 and quadrants 2. 1 and 2. Okay, it's pi over 4. So what's your pi over 4 family members quadrant 1 and 2? It's pi over 4 and 3 pi over 4. So here's your answers, and here are your answers. So you have 4 there as well. Take a moment to look at those 3 examples. Alright, let's look at number 4. Number 4 is cosine squared x minus cosine x minus 2. Alright, let's take a moment to review something here. That was very, very similar to when we factored something like this quadratic. And when we factored this, we did x minus 3 and x minus 2. Well, this is the same concept here, guys. You have cosine squared x minus cosine x minus 2. It's got to multiply, and it's easy because I understood 1 right here. It's the easy method. It's got to multiply to give you negative 2 and add to give you negative 1. Okay? But instead of putting an x and an x here, we would put a cosine x. Because cosine x times cosine x is cosine squared. And it's got to multiply to give you negative 2, add to give you negative 1. Well, that would be negative 2 and positive 1. Alright, now, if you ever want to check, you can fill it out and see if it gives you the same thing you wanted. Alright, now I'm going to set both of them equal to 0. Move this over. Is there a cosine value of 2 in the unit circle? No, so you can mark that out. Cosine x plus 1 equals 0. Move that 1 over. That would be pi. So your only answer for that particular problem is pi. Alright, let's look at number 5. We got cosine to the 4th x plus cosine squared x minus 2. Okay, understood coefficient of 1, but instead of doing cosine squared, it's cosine to the 4th. So instead of just putting like cosine x here, we need to put cosine squared x and cosine squared x, because cosine squared times cosine squared is cosine to the 4th. It's got to multiply to give you 2, negative 2, and add to give you 1. That's positive 2 and negative 1. Set them both equal to 0. That gives you a value of negative 2. It's not a negative 2 value, cosine value, so we don't have to worry about that one. Then cosine squared x minus 1 equals 0. Okay, get rid of that square, you take the square root. Remember, when you take the square root of something, it's plus or minus 1. Okay, where's cosine value plus or minus 1? Okay, remember it's at 0, pi, and 2 pi. So I have 3 answers for that particular problem there. I'm going to go to number 8 and then come back to 6 and 7. Okay, so let's look at number 8. Sine to the 4th plus 2 sine squared minus 3. Leading coefficient 1. Instead of putting just sine, I'm going to put sine squared. So to multiply to give you negative 3, add to give you 2. That's positive 3 and negative 1. That's sine squared x plus 3 equals 0. I move that 3 over, it becomes a negative 3. I don't have a sine value of negative 3 on the unit circle, so I can mark that out. You do not use it. Move that negative 1 over, it becomes a positive 1. Where's my sine value? Oh, now I got to get rid of that square, take the square root. When you take the square root, it's plus or minus 1. Where's my sine value? Positive 1 or negative 1 is pi over 2 and 3 pi over 2. So those are my 2 answers for that particular problem. Alright, I'm going to do number 6 and 7 on notebook paper. Because let's look here. Variable squared, variable, no variable. But coefficient greater than 1, this is bust them up. This is going to be a little bit more intense than 4 and 5. So I'm putting number 6 on notebook paper. 2 sine squared x minus 3 sine x plus 1 equals 0. Alright guys, we got to do bust them up here, and I'm going to do bust them up here without the sine squared x in there. I'm going to treat it like it was x. So I'm going to use what's called, I'm just going to say this, I'm going to let x equal sine x, like that. I'm going to let x equal that, and I'm going to rewrite this as 2x squared minus 3x plus 1, because I can't decide to let x equal sine x. Now, I'm going to do bust them up. It's got to multiply to give you 2 times 1, but add to give you negative 3. So it's going to be 2x squared minus 2x minus x plus 1. Group it off. That's a 2x Only I can take that as a negative 1. So I'm left with 2x minus 1 and x minus 1. Okay, so I factored it. You've got to know how to factor. Okay, now this is where I go back and put sine x in for x, okay? So because there's an x there, I'm going to put 2 sine x minus 1 and then sine x minus 1 equals 0. So I'll put that back in for x. It's just easier to factor when it's just x squared, 2x squared minus 3x plus 1 instead of having all that trig in there. You might get confused. Now, I'm going to set both of these equal to 0. Move this 1 over, so it's going to be 2 sine x equals 1. Divide both sides by 2. Sine x equals 1/2. Okay, so I got to think, okay, where does my y value equal a positive 1/2? My y value is positive in quadrants 1 and quadrant 2, and that deals with the pi over 6 family. So what numbers are in quadrant 1 and 2? Pi over 6 and 5 pi over 6. So there's 2 of my answers. Then I come over here, sine x equals 1, where does my sine value equal 1? Well, that's only at pi over 2. So I got 3 answers. Pi over 6, 5 pi over 6, and pi over 2. Number 7. If you look at number 7, variable squared variable, no variable, and they have a coefficient greater than 1. So this is busted up again. So I'm going to come over here and let x equal sine x again. So 2x squared plus x minus 1 equals 0. It's got to multiply to give you negative 2, add to give you 1. So it's going to be 2x squared plus 2x minus 1x minus 1. That's right. We've got to multiply to give you negative 2, add to give you 1. 2 times negative 2 times negative 1 gives you negative 2, and 2 plus negative 1 gives you 1. Group it off. I can take a 2x out. That leaves an x plus 1. Take a negative 1 out. That leaves an x plus 1. So I have 2x minus 1 and x plus 1 equals 0. I'm going to substitute sine x back in for x. 2 sine x minus 1. Sine x plus 1 equals 0. Set both of them equal to 0. Move that over, so 2 sine x equals 1. Divide by 2, x sine x equals 1/2. Okay, so where's my sine values positive? That's quadrant 1 and quadrant 2, and this is dealing with pi over 6 family. So x equals pi over 6 and 5 pi over 6. Those are 2 of my answers. Move this over here. Sine x equals negative 1. Where's my sine value negative 1 at? That is 3 pi over 2. So those are my 3 answers. These are not bad. I like these. These are fun. Alright, let's look at number 9. I'm going to turn back to the note taker. You have variable squared variable, no variable. Coefficient of 1. So is that easy or busting up? Easy. But it needs to be set equal to 0. Like these ones that have quadratic, 0. So I need to move the 11 over first. So it's cosecant squared x minus cosecant x. That 11 comes over as negative, so it's going to be minus 2 equals 0. So Mr. Esther, I know we don't like working with cosecant. We need to change it to sine. We're going to change that to sine in a little bit. Let's just go on and factor it, and we're going to change it to sine in a little bit. Alright, so we're going to put 2 parentheses down. So that's going to be cosecant x, cosecant x. It's going to multiply to give you negative 2, add to give you negative 1. That's negative 2 and a positive 1. Now I'm going to set both of them equal to 0. I move this over here. That gives me 2. Now this is where, if I'm going to change the sign, I'm going to put sine x and do the reciprocal, 1/2. So I'm looking for where my y value is positive, and it's 1/2. That's quadrants 1 and 2, and that's the pi over 6 family. So x equals pi over 6 and 5 pi over 6. Okay, now I'm going to move this over here. Cosecant of x equals -1. If I flip -1, it's still -1. And that x will be 3 pi over 2. So there's my 3 answers for this particular problem. Okay. So take a moment, look over this, and then I would like you to complete your assignment. It's page 19, numbers 11 through 29 odd. Work on that, please. Page 19, numbers 11 through 29 odd, and we will go over them on Wednesday. Thank you.